All right, well, welcome to the Holmes Family Science Show. Today we've got Olivia and Evan Holmes, along with me, Mr. Holmes, and we're going to be looking at different types of volcanoes. So we've got two different kids with two different volcanoes, and as you can see, they're very different. This volcano represents a Hawaiian volcano that Olivia made, and this represents a volcano like we have around here. So this represents a volcano like Mount Baker. And so I'm going to ask some questions about the volcanoes, and we're going to try to figure out why they have certain shapes, and we're going to learn a little bit about their lava. So Olivia, can you tell me a little bit about your lava? What do you have for lava?
Red lava.
It's red lava. And what's the lava like? Will you go show the camera, stir it for the camera? What's that lava like?
It's like melted ice cream.
Okay, so it's like melted ice cream. Is it runny or is it sticky?
Sometimes it's runny and sometimes it's sticky, but this one is kind of jello-y.
Okay, so does it flow? Would it flow down the mountain really easily?
No, it would flow down really slowly.
Okay, so it would flow really.
Just like there's something blocking it, and then it's and then the thing's going.
All right, so it slowly flows down the mountain. Now, Evan, can you come over here and show us your lava over here? And so over here we've got Evan's volcano. Now, Evan, your lava looks different than Olivia's lava. Can you tell us what that lava is made out of? It's made out of mashed potatoes. And are the mashed potatoes, are they runny? Do they flow like Olivia's lava? No? So what happens in your volcano when a bunch of mashed potato lava gets stuck in the vent? What will happen? So it'll get clogged up and eventually explode. So today what we're going to do is we're going to test this out. We're going to build up pressure using air pressure from a compressor. And we've got 100 pounds per square inch. That's a lot of pressure. But volcanoes will have thousands and thousands of pounds of pressure. So we're going to see what happens. So we're going to take just a moment and we're going to get this set up and we're going to see what happens when we add pressure to these different volcanoes with their different lava. You guys ready?
Yeah.
Are you ready? All right, what we need to do is we need to scoop lava into the hole, into the vent, and we are going to, and I can help you with that, but we're going to be very carefully, we're going to fill up the vents with lava, and I can help. All right.
Is this jam?
All right, let me help. All right, Olivia, can you see lava down the vent?
Yes.
All right, now we're going to add some pressure. I want you to tell me how you think this is going to erupt.
I think that it might go, or it might be like coming up out of it, like an explosion, but shaped as like if you were having a campfire.
Okay, so like a fountain of lava, maybe.
Like, well, not a water fountain, like at part, like a fountain. Well, it might look like you're having a campfire.
Okay, so maybe a little flow. So let's go ahead and see what happens here. We've got it loaded up. We're going to add some pressure now. Oh, look at that. And we can see that there was no explosion, that the lava shot out just a little bit, and now it's slowly flowing down the surface of the volcano.
Yes.
Did it come out like you thought it would?
No.
You thought it would be more explosive.
Yeah.
All right.
Like.
All right, and for that, we'll take a look at Evan's volcano coming up next. All right, Evan, we just watched Olivia's eruption there. It's still flowing very slowly down the mountain, so watch out, it's probably very hot. But yours right here, we have a different type of volcano with a different type of lava. What do you think is going to happen when we add the pressure?
I think it will go.
So you think there's going to be an explosion?
No, I think it's just gonna go and it's just like gonna like whatever stuff you have for Christmas, like that jelly stuff, and go.
Okay, so you think it's going to kind of just flop out. So let's go ahead and take a look. All right, we're going to go ahead and plug this in here, and goggles on. 3, 2, 1. All right. I don't know if you can tell, but we've got glops of lava all over the area. We've got the crater we can see is rimmed with some lava. It's not flowing down, and we had a mini explosion. Is that the type of eruption you thought would happen? All right. Cut. Olivia, looks like your lava is still very slowly flowing out of the volcano's vent, and it's starting to slow down in some places. What do you think about the shape of your volcano? Do you think that runny lava is what makes the shape of your volcano?
I think it's the shape of a cookie, and except there's a little, like, big, chunky lump of chocolate chip.
Kinda. So this kind of looks like a cookie to you. I agree. It does look like a cookie. But do you think that the lava, after it flows out of the vent and hardens, and then it erupts again and it flows out and hardens, do you think that that could give the shape of a volcano that's kind of the shape of a cookie?
Yeah.
Yeah? So runny lava might make this type of volcano. Now, do you know the name of this volcano?
Yes. It is Mauna Loa.
Okay, great. So I know that Mauna Loa is called a shield volcano, and a shield volcano is the shape of a cookie. And so I think you did a great demonstration. Now look, some of this lava right here is about ready to make it into the ocean. You can see it moving very, very slowly, and over here as well. And you were right that the lava would slowly creep over a long period of time. Now what's going to happen when it hits the ocean?
It's gonna flow.
If this was real water and that was real lava, what would happen?
That the only thing that can stop lava is water. So when the lava hits the water, other lava is gonna keep going down, but the lava right here is going to stop, and the water stops
And is
it
it
from flowing into the water
and so does
and
it
making a fire.
So does the lava, when it hits the water, does it harden, you think? Into like a rock, a lava rock?
I think it takes a little while to harden.
Okay, so when it's in the water, it might take a little time to cool off, but then it cools off and then it hardens into a rock.
But yeah, when it cools off, it's going to be into a lava rock.
Lava rock. Okay, great. Let's take a look at Evan's over here. So Evan, your volcano has a much different shape. It's much taller and has a much more pointed top. Do you think that the lava, the type of lava that you have in this volcano, helps give it its shape? Well, how come?
Because it would go down like this, and then maybe it would have smaller eruptions and like.
So you're saying that the
It might have a big eruption first, and then it might have a smaller eruption, bigger eruption.
Okay, so do you think that this one?
The smaller, the higher it goes, the smaller the eruption.
Okay, so we just kind of had a smaller eruption. The whole top didn't blow off like Mount St. Helens. But the sticky type of lava likes to pile up and make a steep volcano, right?
And then it hardens.
Because if the lava doesn't, does the lava in this type of volcano, does it just flow down the side like on that volcano?
No.
So it just kind of piles up there, and then it builds up a lot of pressure. And what happens when it gets to be too much pressure? It explodes. and in a couple volcanoes around here, we've had volcanoes erupt and explode. Do you know the name of any of those volcanoes? So Mount Baker, Mount Rainier, Mount St. Helens have all had eruptions like this in the past, and they explode because the lava is stickier, right? All right, well that's it for the Holmes Family Science Show. We've got two different volcanoes here, a Mount Baker-like volcano and a Mauna Loa-like volcano. You can see there's different lavas, different eruptions, and different shapes. All right, guys.